a car and a truck are driving on the highway, and you could wonder, what's the drag force on the car and what's the drag force on the truck? Well, to solve this problem, we assume that both have the same speed. So let's say they have a speed of 20 meters per second. But to give you an indication, I first have to make a sketch of the car and of the truck. Well, first I draw the car. This is the car with a certain height and a certain width. And then I make a sketch of the truck, which is a little bit simpler. Also with a certain height, the width. Well, the air is, well, we could also draw a little bit. Well, okay, leave it in this way. The wind is perpendicular to this car, so the drag force is acting in this direction. So in this way, the air is passing the car. Well, the question is, to solve this, we have to know what's the surface area acting on this car. Well, test has shown that this surface area is about 0.8 multiplied by the width multiplied by the height. And for the truck, this is about the height multiplied by the width. But you know that for a car this is around 0.6 meters, and this is perhaps, well, what should it be? 1.8 meters. And for a truck, well, let's say this is 2 by 2. It's 2 meters by 2 meters. Gives you a little bit indication. So you see the truck has already a larger surface area than the car. Well, we have found an equation for it. We thought that the force acting on an object was a drag coefficient multiplied by the surface area multiplied by the kinetic energy per unit of volume. So here the speed of the truck and the car are. We assume that the speed is equal and that the air density is similar. Then we only need to know what's the CD factor. Well, the CD factors are determined in wind tunnels. So for a car, we know that CD is around, I have to look first here on my paper, is about 0.33. This is for a car. And CD for a truck is roughly 0.085, which is for a truck. And now you can substitute all the values. First you have to calculate the surface area. Subsequently you put in the speed, which is similar in both cases. And then you can calculate the force acting on the car. And this one, according to my calculations, it is about 290 newtons. And if you compare that with a truck, this is about 979 newtons. So you see there's nearly a factor 4 between these two. So you see that the force acting on the truck is much larger than on the car, what you expect. And as a consequence, this truck needs, of course, more gas oil than the car. Okay, this was a nice example of drag force on a car, but the most important thing is that you see that the effect of the surface area and the drag coefficient in this example.